Your phone died at 2 p.m. today. You plugged it in last night. You barely touched it this morning. No gaming, no streaming, no video calls. And still, by midday, it was dead. You blamed the battery. You blamed the apps. Maybe you even blamed yourself for not charging it properly. But here's the truth that nobody in the tech industry wants to say out loud. Your battery is not dying because of anything you did. It is dying because of something that was installed without your full knowledge, something that runs without your permission, something that is working right now at this very second, even while your screen is completely off. And it has a name. There's a process running on your phone right now that you have never opened. You did not download it. You did not activate it. You did not agree to it in any meaningful way. It came pre-installed, bundled inside your operating system like a tenant that moved in before you even picked up the keys. And every single hour, every single day, it is quietly consuming your battery, your RAM, your processing power, and in some cases, your data, all to power something you probably never asked for in the first place. That something is on-device artificial intelligence. And the invisible engine behind it is called AI Core. Think about what that means for a second. You are carrying a miniature AI server in your pocket. Not a tool you call upon when you need it. A server. Something that is perpetually active, perpetually listening, perpetually analyzing, and perpetually consuming resources. Whether you're using it or not. Most people have no idea this is happening. Most people assume their phone is resting when the screen is off. It is not. Behind that dark screen, a neural network is running. Machine learning models are updating. Background processes are pinging remote servers, and your battery is the one paying the price. Samsung's AI Core service has become deeply controversial, as users have discovered it significantly drains battery life while running continuously in the background. This hidden AI processing engine, designed to enhance device intelligence, has sparked a genuine grassroots movement among tech-savvy users who are now sharing methods to disable the feature, raising fundamental questions about how manufacturers implement AI and whether consumers deserve more transparent control over these resource-intensive processes. But here is what most of those viral posts and forum threads are missing. This is not just a Samsung problem. This is not even just an Android problem. This is a full-scale industry-wide transformation that happened quietly, incrementally, and with almost zero public announcement. Your phone became an AI server and nobody held a press conference. By the end of 2025, up to 30% of all smartphones shipped globally were projected to support on-device AI features, according to a Deloitte study. In addition to built-in assistants like Google Gemini and Apple Intelligence, there are dozens of additional AI applications on the market. ChatGPT, Grok, Perplexity, all of them running layered on top of the AI infrastructure already baked into the operating system itself. Now layer those on top of each other. Now imagine all of them running simultaneously in the background. Now ask yourself, where does all of that computational energy come from? It comes from one place, the battery in your hand. According to testing by Enovix, running AI features on a smartphone can increase battery drain by up to 50%. Read that again. 50%. Not 10, not 20, 50. That is not a minor inconvenience. That is half your battery life, silently stolen by processes you never consciously activated. But here is where it gets significantly more complicated and more alarming. The AI running on your phone is not just one thing. It is not a single app you can find, tap, and turn off. It is a layered ecosystem of interdependent services, each one feeding data into the next, each one triggering background activity in others. The main factors affecting battery consumption from AI are data processing, background operations, and network usage. AI functions often need high computational power. Tasks like image recognition, natural language processing, and real-time analytics are resource-heavy and can drain the battery quickly. But what makes this uniquely dangerous is that the C tasks are not happening when you open an app. They are happening when you think nothing is happening. They are the invisible activity behind your idle screen. Consider what your phone is actually doing when you are not looking. In 2025, smartphones run advanced artificial intelligence locally, on-device AI powers, voice assistants, real-time translation, photo enhancement, and predictive typing. This processing happens continuously in the background, even when you are not actively using the feature. Unlike traditional apps that pause when minimized, AI models often remain active, analyzing inputs like microphone data or camera access to deliver instant responses. Think about what that means for your privacy as much as your battery. The microphone access, the camera access, running in the background, continuously, even when your phone is face down on your desk. And this is where everything changes, because the story most people are telling about battery drain, oh, your screen is too bright, oh, you have too many apps open, that story is dangerously outdated. According to new data from the telecom company Elevate, the usual suspects, like screen brightness or GPS, are not entirely responsible. The real power drain is coming from background PR. OSS is running silently in your pocket. The entire narrative the tech industry has been selling you, manage your brightness, close your apps, turn off location, is a distraction. A convenient misdirection that keeps you adjusting tiny settings while the real problem runs completely unchecked underneath. Let us talk about exactly what AI Core is, because most people have never heard of it, and yet it is living inside their most personal device. AI Core is found on the large majority of modern Android phones, including newer Google Pixel devices and Samsung Galaxy phones running Android 16. AI Core is known for consuming significant RAM, draining the battery, and occasionally sending notifications. It is the foundational layer on which all other on-device AI features are built. Think of it as the operating system beneath the operating system, the invisible platform that every AI feature on your phone stands on. Smart text suggestions, tie-ins, live captions, voice typing, photo analysis, object recognition, real-time translation, all of it runs on AI Core, which means that even if you never consciously open a single AI feature, AI Core is still running, still processing, still consuming power, because the system needs it on standby at all times. AI Core keeps AI models updated and allows them to communicate with other apps. The problem with AI Core is that it takes up a significant amount of storage space and has been linked to increased memory and battery usage. On some devices, AI Core alone consumes multiple gigabytes of storage. On a Pixel 10 Pro Fold, AI Core weighs a staggering 6.7 gigabytes. 6.7 gigabytes for a background service, for something most people have never heard of, let alone intentionally installed. And it is not static. It updates itself. It grows. It expands its data footprint over time as the AI models inside it become more complex, more capable, and predictably more hungry. But here is where it gets worse. Google's Pixel phones are often the most susceptible to AI-driven battery drain due to the deep integration of the AI Core system service. Features like No W playing identify background music playing in your environment and display the song title on your lock screen. It works offline using a localized database and audio processing, which contributes to battery drain. Your phone is less teening to the music in your environment, passively, continuously, without you asking it to. And that listening requires audio processing, which requires CPU cycles, which requires battery. This is not a bug. This is a feature that was designed exactly this way, shipped this way, and earned on by default. The same logic applies to Live Translate, to AI-generated wallpapers, to cinematic photo effects. Google introduced AI-powered wallpapers and cinematic effects that rely on the neural processing unit to add depth or animate full images. These features drain energy because they keep the GPU and NPU active to render 3D warping effects as you move phone, your wallpaper. Your phone's wallpaper is consuming GPU and NPU power every single time you tilt your device. Now, let us talk about what a neural processing unit actually is, because this is where the story stops being about apps and starts being about hardware architecture, about a fundamental shift in how your device was designed to function. Cloud computing is no longer doing all the work. With chips like Google Tensor, devices carry out some AI tasks on their own. A neural processing unit is a dedicated section of the processor engineered to handle the complex math behind machine learning. It powers tasks such as speech recognition, image processing, and live text translation, all of which consume battery power. The NPU is not an optional component you can disable. It is baked into the silicon itself. It is part of the chip that makes your phone run. And because it is always available, the operating system has been architected to use it, constantly, aggressively, and often without visible indicators that it is doing so. What most people are not seeing is the scale of this shift. This is not about one feature or one app. This is ABO. Yet the entire architecture of modern smartphones being redesigned around the assumption that AI will run continuously in the background. Every new flagship phone released in 2025 and 2026, the Samsung Galaxy S26, the Google Pixel 10, the iPhone 17, is built with on-device AI as a core pillar of its functionality. The NPU has become as essential as the CPU. And just like your CPU, it draws power. Just like your CPU, it generates heat. And just like your CPU, when it is running at high load, your battery drains faster. The difference is that your CPU only runs hard when you are doing something demanding. The NPU runs hard whether you are doing something or not. Background app refresh is one of the top contributors to unexpected battery depletion, especially on devices used heavily throughout the day. Social media apps constantly refresh feeds, weather apps update forecasts, and streaming services preload content. Individually, these might seem like tiny drains, but collectively they can significantly shorten the time between charges. Now add AI processing on top of that existing background activity. Now add machine learning model updates. Now add continuous environmental listening. Now add AI-powered notifications that require background monitoring to function. You are not dealing with a single drain. You are dealing with a compounding, layered, perpetually active drain that never fully stops. Not when you're sleeping, not when your phone is in your bag, not even when you're actively trying to preserve battery by turning your screen off. Here is something that the major tech companies have been very careful not to say clearly. The AI features they are promoting as quality of life improvements are in direct conflict with the battery life they are also promising. A 2025 survey from CNET found that only 11% of US smartphone owners upgrade their devices because of AI features, down 7% from the same survey in 2024. For most buyers, priorities have not changed. Price, longer battery life, and more storage still top the list. 54% of people surveyed said battery life was their primary concern when choosing a new PH1. 54%. And yet every major manufacturer is pushing AI harder than ever, deploying features that directly attack the one thing consumers care about most. This is not an accident. This is a calculated trade-off that the industry made on your behalf without asking you and without telling you clearly what you were giving up. AI-powered apps often use machine learning models that continuously learn and adapt to user behavior. This requires regular background processing to update models with new data, contributing to battery consumption. AI-driven notifications, such as reminders from virtual assistants or alerts from health monitoring apps, rely on background monitoring to provide timely information. And constantly checking conditions to trigger these notifications also drains the battery. Every smart suggestion your keyboard makes, every notification your AI assistant surfaces, every time your photo app silently categorizes a new image in your gallery, every time your phone listens for your wake word, every single one of these micro moments costs energy. And because they happen dozens, sometimes hundreds of times per hour, the cumulative cost is enormous. And now the picture gets even more complicated because the drain is not coming from just one direction. Many AI applications offload complex tasks to cloud servers to save on-device resources. To optimize network usage, using Wi-Fi instead of mobile data reduces battery drain from network activities, and disabling automatic data synchronization for apps that do not need real-time updates also helps. This is the hybrid model. Some processing happens on your device, some gets sent to remote servers, and the communication between the two requires constant network activity. Every time your phone pings an AI server in the cloud, it uses cellular or Wi-Fi radio power. Every time it receives a response, it uses more power to process and display it. The AI is not just running locally, it is running a continuous back and forth conversation between your device and servers halfway around the world. And your battery is funding every single transmission. Now, here's the part that should genuinely alarm you. Independent battery telemetry from GSM Arena's 2024 Device Power Lab shows that devices running iOS 17.5 or Android 14 QPR3 with enabled smart vision services consumed 18 to 22% more power during idle periods than identical models with those services disabled during idle periods. That means when you are not touching your phone, when it is sitting on your desk, when you think it is resting, it is consuming almost a quarter more battery than it should be. Not because of anything you are doing, but because of background AI vision processing that was turned on by default. And this is on devices that are less than a year old, devices that were marketed as having exceptional battery life. The marketing is based on tests run without these AI services active. The real-world performance, with AI running the way it is designed to run, is something else entirely. Let us talk about what you can actually do, because knowledge without action is just frustration. The first thing you need to understand is that there's no single switch. No magic setting that turns off all AI background processing at once. This is not an accident of design. It is the result of AI being embedded so deeply into the operating system that disabling it completely would break core functionality. But there are specific, targeted actions that can reclaim significant battery life. And they require you to go deeper into your settings than most people ever go. On Android devices, particularly Samsung and Pixel phones, the process begins with understanding what is actually consuming your battery. Go into Settings, then Battery usage. What you're looking for is not just the obvious apps at the top of the list. You're looking for system services, for background processes, for anything that shows significant battery consumption during periods when your screen was off. Look for any apps consuming more than 15% of your battery without being actively used. Also watch for any system processes that seem unusually high. If you see AI Core, Samsung's customization service, Google's AI services, or any process labeled with terms like intelligence, vision, or core appearing in that list with significant battery usage, you have found the culprit. For Samsung users specifically, the steps to address this are more involved but highly effective. Battery life extensions of 10 to 15% are commonly reported after addressing AI core, while some users claim even more dramatic improvements depending on their usage patterns. To disable AI core on a Samsung device, go to Settings, then Apps, then find the option to show System Apps. This is critical because AI core is hidden by default in the standard app list. Once you find it, you have the option to disable it. Before doing so, understand the trade-offs. Disabling AI core could cause issues with live RS captions, voice typing inaccuracies, smart text suggestions in your keyboard, slower system intelligence features, and random crashes. This is not a decision to make blindly. It is a decision to make informed, weighing the battery gains against the features you actually use and value. For Google Pixel users, the approach is different because the AI integration runs even deeper. Google's Pixel phones are often the most susceptible to AI-driven battery drain due to the deep integration of the AI core system service. NOW playing, the feature that identifies background music playing in your environment, can be disabled by going to Settings, then Sound and Vibration, then Now Playing, and toggling off Identify songs playing nearby. Live Translate can be found under Settings, the End system, then Live Translate. These are small steps, but each one stops a continuous background process from running, and the cumulative effect of stopping multiple background AI services is measurably significant. On Samsung's Galaxy S26 series, running One UI 8.5 based on Android 16, a feature called Nearby Device Scanning continuously scans for Bluetooth and Wi-Fi devices in the background, even with no active pairing in progress. A Samsung community post identified it as a cause of battery drain, grouping it with two other always-on connectivity features, Continue apps on other devices and SmartThings, that similarly increase background battery consumption. These are not obscure, rarely used features. These are default behaviors that run on every new Samsung device the moment you turn it on. And most users will never know they exist, let alone know how to turn them off. Beyond the device-specific steps, there are broader strategic changes that can fundamentally alter how much AI is consuming your battery. Disabling background app, refresh prevents apps that do not need up-to-the-second updates from constantly checking for new data. Using battery saver mode automatically restricts background activity and visual effects. Lowering brightness remains one of the most effective ways to conserve power. But beyond these standard recommendations, the deeper move is to audit every AI feature you have enabled. Not Joe. This ain't the ones you use actively, but the ones that were activated by default during setup. AI wallpapers, AI photo categorization, smart suggestions, predictive app launching. Each one is a small drain. Together, they are a significant one. Embracing adaptive battery, the smart feature usually found in battery settings, learns your app usage habits and intelligently restricts background activity for apps you do not use often. The paradox here is real, using AI to fight AI. Adaptive battery uses machine learning to identify which background processes are unnecessary and throttle them. It is one of the few cases where on-device AI is actually working in your favor rather than against you. But even adaptive battery has limitations. Adaptive battery assumes all users behave like average consumers. But nurses, drivers, security personnel, and caregivers operate in always-on contexts where prediction fails. Manual, context-aware tuning is not a workaround. It is responsible system administration. The AI managing your battery does not know your life. It does not know that you need your navigation app ready in an instant, or that your health monitoring app cannot afford to have its alerts delayed by 47 seconds. The system makes assumptions, and when those assumptions are wrong, you pay the price. Here's the bigger picture that most tech commentary is completely failing to address. This is not a temporary problem. This is the direction the entire industry is moving, faster and more aggressively with every product cycle. ARM introduced its new Lumex platform featuring C1 generation CPUs, designed to deliver up to 5x improvement in AI performance, 4.7 times lower latency for speech-based workloads like live translation, and 2.8 times faster audio generation, with the goal of achieving faster AI performance without increasing battery drain. The chip manufacturers are working on the problem. The NPU efficiency is improving. The promise is that future hardware will handle all of this AI processing without the battery penalty we see today. But that promise is measured in product cycles, 2, 3, maybe 4 years away from being meaningfully realized for the average consumer. In the meantime, the software is pushing AI features faster than the hardware can efficiently support them. Yet the features and functionalities that leverage these new AI technologies will be there, ever present on your device, silently consuming vital resources like storage and memory. This is the fundamental tension that nobody in the consumer tech space is resolving honestly. The AI is here, it is embedded, it is running, and the efficiency gains needed to make it sustainable are still being engineered. You are living in the gap between the ambition of the feature and the reality of the hardware, and your battery is the collateral damage. What most people are not seeing is that this represents a fundamental shift in the relationship between consumers and their devices. For decades, your smartphone was a tool that you controlled. You opened apps when you wanted to use them. You closed apps when you were done. The device was reactive. It responded to your input. What we are describing now is something categorically different. Your phone has become proactive. It is making decisions about what to process, what to analyze, what to prioritize, continuously, autonomously, and largely invisibly. The question of who controls that decision-making process, and whether you, as the owner of the device, have meaningful authority over it, is one that the tech industry has not answered satisfactorily. The informed sources who track power consumption data at the system level are clear. The gap between marketed battery life and real-world battery life is growing, not shrinking. The more AI features get embedded into operating systems, the wider that gap becomes. And because the features are enabled by default, because the manufacturer's interest is in demonstrating AI capability, not in conserving your battery, the burden of optimization falls entirely on you, the user, to navigate menus and settings that most people were never meant to understand. So where does this leave you? It leaves you at a decision point that the industry never clearly offered you. You can accept the AI features as shipped, accept the battery trade-off, and charge your phone more frequently. You can surgically disable the most aggressive background processes. AI Core, Now Playing, Live Translate, AI Wallpapers, Nearby Device Scanning, and reclaim meaningful hours of battery life at the cost of some features you may or may not have been using anyway. Or you can go deeper into developer options, into system-level battery management, and take a level of control over your device that most manufacturers prefer you never exercise. But there is a fourth option, and it is the one that nobody is talking about loudly enough. You can demand transparency, because the real issue is not that your phone has AI. The real issue is that it was deployed without clearly explaining to you what it was consuming. You were shown the features, you were not shown the cost. The wallpaper looked beautiful. Nobody told you it was running your GPU and NPU in the background every time you tilted the phone. The live translation was impressive. Nobody told you it was continuously monitoring your environment to be ready. The smart suggestions felt seamless. Nobody told you they required constant background processing to generate. This is the pattern. This is the strategy. Capability front and center, cost hidden in the background, literally hidden in background processes you were never meant to find. And the deeper question, the one that sits underneath all of this, is whether the trajectory changes, whether the next generation of devices comes with genuine transparency about what AI is running, what it is consuming, and what control you actually have over it, or whether the features keep multiplying, the background processes keep compounding, and the gap between the battery life you were promised and the battery life you experience keeps quietly widening. Because right now there is a silent AI server running in your pocket. It was put there by the world's most powerful technology companies. It is consuming your resources around the clock. And most of the people whose phones it is running on have absolutely no idea it exists. The question is not whether you can disable it. The question is why you had to find out about it from a YouTube video instead of the company that sold you the device. And if they were not transparent about this, what else are they not telling you?